Yeah, banner. We have the video in this group, so please watch the video. And if you have question, yeah, please ask me. Now, yeah, okay. And let's start today's the third content. Okay, we learned how to use the Tsquare to test the godliness fit with equal or unequal expected frequencies, right? Okay, and now, next, yeah, we also the Tsquare test can be used for relatedness or independence. Okay, here shows an example. For example, a fashion manufacturer wished to determine whether color reference for t-shirt. Okay, yes, please look at here. Color reference for t-shirt depended on geographic location of the consumers. So whether color preference for t-shirt dependent on geographic location of the consumer. Okay, so for this sentence, we can see which is the dependent variable and which is the independent variable. Okay, could you? Can everyone tell me color reference for t-shirt and location of the consumer? Which is the dependent variable? Which is the factor or which is the independent variable? Okay, the preference for t-shirt is dependent variable, and geographic location of the consumers is the factor, also it's called an independent variable. Okay, so we will conduct the survey. Okay, and with the respondent, we know that those who select preferring the red, yellow t-shirt, 32 are urban consumers and 24 are rural consumers. Of those who choose black, white t-shirt, 28 are city consumers, while 4 are rural consumers. Okay, here the data can be found in number 2, the color preference for t-shirt. Okay, and also location 1 refer to urban, 0 refer to rural. Color preference 1 refer to red or yellow, 0 refer to black or white. Okay, here, if the proportion of color preference for t-shirt has no significant difference, right? So it can be concluded that color preference for t-shirt doesn't depend on geographic location of the consumer. So that means we will compare if there has significant difference between the rural consumer and the urban consumer. If they are different, then it means the geographic location of the consumers has significant impact on color preference for t-shirt, right? Okay. Otherwise, it means the color preference for t-shirt has no relate with the location of the consumers, right? So it's for the relatedness or independence. If these two variables are independence or relate, or they have some relation, they has the relatedness. Okay. Now, let's look at the data file. Yeah, please open the color preference for t-shirt. Okay. Here, we have the location, color, and frequency. In this case, you need to establish 3 variables. 1, location. 2nd, color. 3rd, frequency, right? Okay. And we will test if the location has significant impact on color preference. Okay. Now, yes, for a test like this, we will use the Tsquare test because you see the dependent variable is a frequency. Location is nominal. And 1, open, 2, ruler. Let me see if it's right. One is open and 0 is ruler, right? So I'll change it. 0 is ruler according to the note. Remove the 2 here. Okay. 1 is urban, 0 is ruler, right? Okay. And then here, color here. Yes. Black and white, 0. Yellow or red, 1. Yeah, it's correct. Okay, then next is the frequency. The frequency here, the measure of frequency is the Tsquare. So we need to change to Tsquare. Okay? Yeah. Now we will test if the proportion of color preference of the urban consumers and rural consumers has no significant difference. If, right? So here is the hypothesis. Okay, so we need to use the Tsquare test. Analyze here. Okay, and then still non-parametric tests. Yeah, the last one, legacy dialogues. Okay. Yes, I'll share. Sorry. Yeah, sir. Yes, my suggestion is, okay, everyone, would you please establish the data file by yourself? Okay, yes, I think that will be better for you to understand how to establish the data file. Okay, yeah? Okay, so please establish the file. Okay. Okay. Yeah. You can have 2 forms to, you can establish the data in different way. Okay, yeah, I need to close them because there are too many of them. Okay, here's one way to establish the data file, right? And Tsquare, yeah, established another types of data file. It also can use. Okay, so here, yeah, firstly, I would like to use Tsquare's file to analyze. Okay, yeah, here Tsquare use two variables. One variable is location. Another variable is color preference. Yes, good. See? Yeah, and the value labels, yeah, correct. The location, the location of the consumers, correct, right? Okay, and also, yes, user, please change the measure here. The measure here is the nominal, right? Because the ruler and open, they are nominal. The color preference here, we can use the nominal here. Okay, because there is black, white, one is yellow, green, right? Okay, yeah, and then save it. Save this document. Okay, now here, if the x1 1 here means the if one consumer select he or she prefer the yellow or green, then we will record one here and one here, right? So it means this consumer prefer yellow, white. Yeah, and also here yellow, white prefer. So yeah, totally, how many people select yellow or white? Let me see here. Okay, totally. Let me see here. Totally. Yes, open paper, because the location 1 means the open, right? So, yeah, let me see, analyze it. I want to see if it's correct or not. Then I use frequency here, and color preference, no, sorry. I will use the descriptive statistics, the cross tapes, and the row is location. The column is color preference. Look here. Yes, the ruler paper, if it's black and white, the color preference is 0. Ruler paper 4 paper, open 28. Totally 32, right? And then here, the location. The color preference, if the color preference is red or yellow, then 24 ruler paper prefer, and 32 urban consumers prefer, right? Okay, yes, it fits. Yeah, they're the same. right? They are just the same here. Yeah, they are same, right? So that means, yeah, this and this. Okay, so these are words expression, and here is the all the data are collected in a table, right? They're the same. Okay, so if I give you the table like this, then you can use these numbers to establish a file like this. You can establish a file like this. It means totally 32 people and 32 urban people prefer yellow, white. Here, totally 28, the urban consumers, they choose white or black. Okay, so here, when 0, 1, 0, 1, 0, 1, totally we have 28. Here is the rural people. The rural consumers who prefer red or yellow, because one is red or yellow. So here we totally have 24. Yeah, so we have 1, 0, 24, 1, 0 here. Finally, here is white or black, and here is the rural people. So here totally 4 rural people prefer black or white. Okay, so you establish a file, data file like this. Okay, yeah. So if you establish a data file like this, then when you conduct the Tsquare test, yeah, you don't need to wait cases. Okay, so you don't need to wait cases. You just directly click Analyze here, Descriptive, Course Tips. Okay, and here I already enter the location to row, the color preference to columns. You also can use the color preference to rows and the location on columns. No, yes, that's no problem, okay? And then here, statistics. Statistics, yes, please click statistics and select Tsquare. Okay, so here we have a Tsquare. Now, if you test two variables relatedness or dependent, then you will use the cross tab at you use the Tsquare at cross tabs. Okay, this is very important. It's different Tsquare. Okay, there are different Tsquare. Now you use the Tsquare here. Okay, so this time, if you establish a data file like this, then you don't need to use weight cases. Directly, you will use the cross-tabs Tsquare. Okay? Okay, select Tsquare, continue here. And then, okay. Now, you have the Tsquare test, the result shows here, right? And yeah, what do we look at? We will look at the Pearson Tsquare here. Look, here is the Tsquare test result, and look at this row. Okay, the toppest, the first row. Pearson Tsquare. The value of Pearson Tsquare is 8.650. Okay, and the corresponding significance is 0.003, which is less than 0.01. Okay, so that means the color preference between rural and open consumers are very significantly different. Okay, so also it means the location of the consumers and color preference, they are dependent. Okay, because if the consumer is rural, whether the consumer is rural or urban, the color preference, yeah, the frequency will be different. Okay, yeah, yes. So please look at the Pearson Tsquare, this row. This shows they are significantly different. Okay, also you can draw the chart. Okay, I'll repeat. Analyze, descriptive statistics, cross tabs, right? Okay, yes, you can display clustered bar charts, right? Yes, you can select here. Because they are totally different. They are significantly different, right? Okay. Yeah, so you can draw the chart here. Yeah. Here is the location. And here is the color preference. Yeah. Look here. Yeah. The urban people and the rural people, for the red and the yellow, yeah, it looks like they are similar, right? But for black and white, you can see that the less rural people, they prefer black or white. Okay, so here shows so that means higher proportion of the urban people prefer the black or white than the rural people. Okay, now with this analysis, we find out, okay, so that we find out that the color preference for t-shirt between urban consumers and rural consumers are significantly different. Okay. Okay, next, let's look at next. Yes, the data file we established like this. Okay, so we will use this file, yeah, to analyze the same question. If the color preference between urban people and rural people are same, okay, the same hypothesis. Okay, because this time here we establish 3 variables: location, color, and frequency, right? Since here is frequency, so we need to weight the cases. Here, data here, weight cases. Yeah, same like the example 1, right? The first example. And weight cases by, yeah, also here, weight cases by frequency. This is the weight cases by. Look, right? And then, okay. Okay, so now we complete weight cases, weight the frequency here. Okay, next we will use analyze here. Descriptive here. If we use the frequencies like this, then we will use the statistics. Let me see here. Where is statistics? Okay, statistics here. And the frequencies, cross tabs here. Okay, and also location, row, color, columns, right? And statistics, Tsquare here, continue. Display cluster bar charts. Okay. Yeah, look. So everything is same, right? When it runs, they are same. The Pearson Tsquare 8.650. Okay, and the significance less than 0.05. Okay. Yeah, the result is the same. Just the operation has a small difference. Because if you establish the file like this, you use frequency, then you need to weight cases. Okay, if we use the data file established by GSO, then we don't need to weight cases. Okay, can you understand? Okay, now we completed okay, then we completed number 2. Okay, we use the Tsquare for relatedness or independence test.